Okay. Hello. Okay. So let me share my screen and let's see what we can do. Okay, so we are still on this page. We see that whenever we want to try to find the best level of error, we try to do this kind of what? Gradient descent or optimization. So let's see. Now, so this is our general formula over here. When we come to this formula, we see that our J, which is the what? The cost function or the loss function, is given by the error raised to the power 2. So how do I tackle that? Or what are the parameters given? The error at the time that we are talking about is equal to what? 4. Then our learning rate is equal to 0.1. So it's simple. What we are supposed to do over here is to just differentiate this. We are going to differentiate the what? The J with respect to theta. So when I do that, what do I get? That is partial differential of what? J with respect to what? D of what? Theta, which will give me, we know that if this one is the same as J to be equal to x raised to the power 2, the differential of x raised to the power 2 is just 2x. You all know that. That is what? 2 theta. But then we want to find our new error. So my new error, which is what? Theta 2 or theta new, will always be given by theta old minus what? Learning rate multiplied by the whole of this, which is what? D of the J divided by what? D of what? Theta. So what are the values? The values are, we have our old error, which is what? 4. 4 minus, what is the learning rate? 0.1 multiplied by the differential of J with respect to what? Theta, which is what? 2 multiplied by J, multiplied by theta, which is what? 2 multiplied by 4 here. So at the end of the day, we have 4 minus 0.1 multiplied by 8. So 4 minus what? So what is 0.1 multiplied by 8? That will be 0.8. So when we subtract it, we are going to have, I think it should be 3.2. So the answer will give us 3.2. It's very simple, please. 3.2, simple. Now let's go to our next question. The same thing applies to this. We have the differential of the cost function with respect to what? Our theta is equal to what? 2 multiplied by theta, the same thing. So when I come in here, I'll have my new error, maybe theta n, to be equal to what? Theta old minus learning rate multiplied by 2 multiplied by what? Theta. So the answer will give me my old error minus 0.1 multiplied by 2 multiplied by 6. That will give me 6 minus what? 1.2. And the answer will give me 4.8. As simple as that. Okay, so that's all for that. Now, what is the rule of the gradient descent? Please, all these things, you have to take them very carefully. What do we use it for? We use it to reduce the difference between our predicted and actual value. You see the difference of your predicted, you see the actual value is what is there, the real one that is there, and you are predicting something. So we have what? We have y actual minus y predicted. The actual thing is maybe 10, and you are predicting 9. The difference becomes 1, and the difference over there is your what? Is your error. So we use this gradient descent to minimize your error. So whilst we work towards our gradient descent, the error will be minimizing or will be reducing. And the error over there is just the difference between the predicted value and the actual value. Simple. We use it to optimize the model parameters. Anytime you try to do the what? You use the gradient descent to do the optimization. You upgrade something in your brain or you upgrade something in the model. And that thing is what you call the parameters. At first, I was thinking this guy is called Kwajo. Oh, no, knowing he's not called Kwajo, he's now Kofi. So I've saved it in my brain. That is the weights or the parameters that I've saved. And tomorrow, if somebody asks me of the names, I can now predict very well because I've now improved in what? In performance. So it is used to also optimize model parameters. It helps us to enable our training of complex models. Examples of these complex models are linear regression, logistic regression, and neural networks. Then it helps us also to improve the model accuracy. If you are reducing error, then your accuracy is going up. It's the other way around. Simple. So what are the impacts? After we've been able to do our optimization, what is the impact on our whole machine learning works that we are dealing with? It finds the best parameter. So at the end of the day, the best parameter will be saved in your brain or in the model. It reduces the loss function. It ensures convergence to optimal solution. Whilst you are doing that, you'll be approaching the optimal solution. So at first you were thinking this guy is like this one is, the name is this. But as time goes on, before you complete school, you'll be able to memorize a lot of people's name in the class. Some people can even memorize everything. It tells you that everything has converged. And it helps us to converge to an optimal solution. And the optimal solution is the best solution that we ever have. It allows models to learn from data. So the data will be there, learn it, predict, get mistake, correct yourself, optimize, reduce the error, try again. All these things that you are doing, it means you are learning from what? Data. And that is all about machine learning. Fine. So let's talk of linear regression. So let me push this thing let me push the old one before I deal with this kind of linear regression for you. Thank you.